Okay, continuing on with 12.4 counting. Okay, we went over two methods in the first video: the fundamental counting principle, different topics, different categories. Find out how many outcomes each category has, you multiply across. The factorial, which you have a set of items. Every one of those items needs to be placed in order. So you start with the total number of items and multiply across going down each time. The factorial symbol is allowed to be used for a shortcut. In this video, we're going to be looking at permutations. Now, the permutation, how to know when to use a permutation is not every item in the list is being used, and order matters. Okay? Meaning, if things are put in a different order, it might be the same items, but if they're put in a different order, that would count as another topic. That would count as another one of your tallies for how many different ways you can move them around. Okay? Now, again, where do I use the shortcut? If you remember from the binomial distribution, we use the NCR for combination. Well, for permutation, it's going to be NPR, our total number of items, and then R is how many we're choosing of those items. So here's an example. There are 18 kids in a class. You were making a seating chart with 6 front row desks. How many ways can the kids sit in the front row? So if you're looking at the 6 front row desks, okay, pretend they are normal desks, and we have start at this side, we have student 1, 2, 3, 4, 5, 6. So there's our 6 students sitting there, okay, out of the 18 students. Well, that's one front row I could have. If I just take student 1 and student 6 and switch them, is that still the same front row? 2 students moved. Okay, so that's not exactly the same front row. Now 6 is next to 2 and 5 is next to 1. So that's how I mean by order matters. Now the way I'm going to plug this in, you plug in your total first. So we have 18 total students. Same place where the factorial was. Math, PRB, that's where you're going to go to the NPR for the permutation, and we're picking 6. There's 6 front row desks. Okay? Again, some of your answers are going to be fairly big. For this one, I have 13,366,080. Okay? So again, some of your answers are going to be fairly big, so take your time writing them out. Okay? Total of 18, we only use 6 of the items. Okay? 18 students, we are only picking 6, so not every item is being used. And if those same 6 items are moved around, the order matters. Okay, so that's what it means by order matters. Our next example here. You're in a contest for the best homemade hats to wear to the horse races. There are 20 people that are in the contest. First place gets 100, second place gets 50, third place gets $10. How many ways can the competitors finish? Okay, so we have 20 total people, but only the top 3 are going to get prizes, and those prizes are different. So what you need to think about in this situation, does order matter? Well, if you come in first, you get $100. If you come in second, you get $50. Does it matter if you come in first or second? Yes. Okay, there's a different prize there for each person, so order matters. That's how you need to think about it. If you come in first, are you getting the same thing as if you're picked second? Okay, is second place getting the same as third place? If the answer is no, that means order matters. 20 total people, NPR, 3 people are getting prizes, and I have 6,840 for my answer. All right, so there's 2 examples of permutation, basic permutation problems. Now, kind of what I think is a subgroup of permutation is if you're just taking items that repeat, okay? So how many ways can you arrange the letters in? Now, we're going to be looking at words, and we're going to be moving these letters around. How many ways can we rearrange those words? Okay? This is really going to be the same concept as if it was any items. I'm looking at letters, but it could be any items that we could be looking at. So the first one, I'm looking at Mike. There's 4 letters, and how many ways could you rearrange those? Well, if I just put a number above each letter here, 1, 2, 3, 4, this is the same concept as those friends going to sit down. In that first spot, 4 people could sit. Here it's just 4 letters. The next there's 3 letters, 2 letters, then 1. And if you multiply across, that would give you your answer. So you end up with 24, which also would be 4 factorial. Okay? So if there's no repeat letters, you can just do the factorial for how many total letters there are. Now for a word like booth though, there's 2 O's. Okay? If those O's are the only 2 things that switch spots, is that really a different word? No. So the way we're going to do this is n factorial divided by r factorial, r factorial, r factorial, and those r's represent how many letters repeat. Okay? So depending on how many letters repeat will depend on how many r's you have in your denominator there. The n is your total. So we have total up here and the repeats down in the bottom. Okay, so for Booth, there's 5 total. 1, 2, 3, 4, 5. And O repeats twice. So since 2 O's, 2 factorial. Now make sure each value has its own factorial symbol. 5 factorial divided by 2 factorial, and that should give you, so again, I don't really remember the answer off the top of my head. I have it as 60. Okay? So you need to think how many letters repeat and how many times do they repeat. Mississippi, M-I-S-S-I-S-S-I-P-P-I. So this time, there's a whole bunch of letters here. We have 11 total letters, and we have a whole bunch of repeats. So I'm just going to start I's, and the I's repeat 4 times. I'm going to put an I below just to keep track. There are 4 S's. So that's another 4 factorial. And there are 2 P's. Okay, so there's all the letters that repeat. Now, if you're plugging this into your calculator, make sure you put that denominator in parentheses. Okay? Putting that in parentheses is important because order of operations. You want to multiply all those values in the denominator first before you do that division. And this should give you 34,650 different ways to rearrange those letters. Now again, this is an example using letters. It works with any object. So if I want to change the example just a little bit, you have 6 blue, 3 red, and 4 green marbles. How many ways can you rearrange those marbles? So let's just look at a picture here. Okay. We have 6 blue, 1, 2, 3, 4, 5, 6. We have 3 red, 1, 2, 3. And we have 4 green, 1, 2, 3, 4. So there's all of our marbles lined up. Well, this is the same concept as the letters. Now if I just took this and just made the letters A, B, 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 and C, 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 well, it's the same thing as moving them around. If I take these 2 A's and switch them, would that be any different? No. So just because they're colored marbles and not letters this time, it's done the same exact way. There are 13 total, and then the repeats here. Okay? There are 6 blue, there are 3 red, and there are 4 green. Don't forget your parentheses in the bottom, and that should give you 60,060 for an answer. Okay, so the concept's the same, the objects are different. Okay, so that's on the permutation, and then we have one more video kind of to do one more method of combination and put it all together.